In core 1 we looked at differentiation, but we never really applied it to any real life situations. Well, in core 2 we have to apply differentiation to real life situations and look to see whether solutions are going to give us a maximum or minimum value to various problems. Now we're going to have a look at this problem here, which says a manufacturer wants to make a cylindrical can to hold 250 pi centimetre cubed of soup. Find the dimensions such that the surface area is as small as possible so that the cost of the can is as low as possible. Now that makes sense, because obviously when companies are trying to manufacture cans, they want to try and keep their wastage as small as possible, so they need to make their product as small as possible using less materials. Makes sense. Right, we're told that this can holds 250 pi centimetre cubed. Now we should know how to find the volume of a cylinder. To find the volume of a cylinder, we should know that the volume is equal to the area on the top, which is pi r squared, times by the height. And we're told that is equal to 250 pi. So this is 250 pi is equal to pi r squared h. Secondly, we can also find something else about this question. We kind of hinted at it in the question. It says find the dimensions such that the surface area is as small as possible. So we need to now write an equation for finding the surface area of this cylindrical tin. So surface area is equal to, now at this point it might be handy just to sketch yourself the parts that make up a cylinder. So we've got two circles. Now remember, we're dealing in radius here, so the area of each of these two circles is going to be pi r squared, and we've got two of them, so it's going to be 2 pi r squared. Now the more difficult part is the area of the rectangular section here. Now we know that this side here is the height, but where does this top bit come from? Well, this top section comes from the circumference of the circle. Now as we're in radians, it's going to be 2 pi r, so that top length is 2 pi r. So to complete our equation is 2 pi r h. Now the problem we have in both these two equations, the one here and one here, is that we're dealing with two variables. Remember that pi is just a constant value, but we've got two variables, the radius and the height. So what we need to do is we need to rearrange one of these two equations to help eliminate one of the variables in the other equation. Now the easiest one to do is going to be to look at our volume equation here and convert it so that h is the subject of the equation. So up here we want to now change this equation so that instead of having 250 pi equals pi r squared h, we want to change this to 250 pi, and we're going to divide by pi r squared. We're going to divide both sides by that to leave h. Now we can of course note at this point that you can cancel out your 2 pi's there, so we're going to be left with h equals 250 over r squared. Now we can take this new equation and we can substitute it in where h is in our surface area equation. Now to help with this, I'm just going to change this from surface area just to area. So area is equal to 2 pi r squared plus 2 pi r in brackets 250 r squared. Right, and if we start to tidy this up a little bit, so we're going to multiply this section here we're going to have area is equal to 2 pi r squared plus 500 pi. Now we've got an r on the top and r squared on the bottom, so that is just going to become r. Now, the next step to do is to change the 500 pi over r to 500 pi to the power of times r to the power of minus 1. So, here we go. Now, this is the difficult step, is to find out what the value of r is. We need to find out where the change in the area is going to be equal to 0. So to do that, we need to differentiate this equation and then set that equal to 0. So if we differentiate this line, dA by dr, we get 4 pi r minus 500 pi r to the power of minus 2. And if you struggle with that line of differentiation, go back to your core 1 videos and rewatch differentiation videos. Now, we're looking for the rate of the change of area of being equal to 0. So we're going to set this equal, this line we've just done, equal to 0. So we're now going to do 0 equals 4 pi r minus 500 pi r to the power of minus 2. So we rearrange this a little bit, so we're going to have 500 pi r to the power of minus 2 equals 4 pi r. And if we divide through both sides by 4 pi, 500 divided by 4 is 125, and pi divided by pi will be 1. If we change this r to the power of minus 2 to 125 over r squared, and that's just equal to r, because remember we divided through by the 4 pi. Next step is to multiply both sides by r squared, so we're left with 125 is equal to r cubed. So that means r is equal to 5. So when there is no change in the area, the rate of change of the area is 0, the radius is 5. Now we can use this radius being 5 to help us now find the height of the cylinder. Now we formed an equation earlier on here to help us find the height when given the radius. So we're going to substitute our radius of 5 into that equation. So sub r equals 5 into the height is equal to 250 divided by r squared. So h is equal to 250 divided by 5 squared. Well, 5 squared is 25, so 250 divided by 25 is 10. So the height is 10. Now, we've now found the values for the two variables r and h. But the final thing we're asked to do is we're asked to show that the surface area is going to be as small as possible at this point, because remember we're trying to get the manufacturing costs down by using less material. Now what we've looked at is we've looked at maximum and minimums in core 2 in previous videos, and what we need to do is we need to differentiate our area dA by dr again to help us find out whether at the value of r equals 5 whether we have a maximum or minimum value. Hopefully we have a minimum value. So remember, our dA by dr we've calculated as being the following. I'll just write it out again for us. So we got this, we got 4 pi r minus 500 pi to the power of r to the power of minus 2, And if we find the second differential now, we're going to get 4 pi minus 2 times minus 500 is 1000, and then we're going to have pi r to the power of minus 3. And we're going to substitute in our value of r that we're using, which we found as being 5. So we're subbing that in. So hopefully 4 pi add 1000 pi over r cubed. Well, r cubed is going to be 5 cubed. So here we go. 4 pi plus 1000 pi over 125, which is 8 pi. So we've got 4 pi plus 8 pi, which you'll find is 12 pi. It's equal to 12 pi. Now, as this value is a positive value, so d squared a by d r squared is greater than 0, we have ourselves a minimum value. So we can apply differentiation to real life situations and problems like raised here, where we had to form two equations, which is quite often the case, and to substitute one of the equations into the other equation to eliminate a variable, and then by differentiating find one of the values to help us find the second value, and then finally to discover whether we have a maximum or minimum value by differentiating by finding the second differential of one of the equations.